Welcome to the Real Python Podcast. This is episode 262. What went into developing the open source Python tools data scientists use daily? This week on the show, we speak with Travis Oliphant about his work on SciPy, NumPy, Numba, and many other contributions to the Python scientific community. Travis discusses his initial involvement in the open source community and his discovery of Python while working in biomedical imaging. He was trying to find ways to manage large sets of numerical data, which led to his initial contributions and collaboration to build scientific libraries. His appearance on the show coincides with the release of the Python documentary, in which he's featured. We discuss the myriad organizations Travis founded, including Quansight, OpenTeams, and Anaconda. We dig into his underlying mission to continue fostering the growth of the open source scientific computing community. This episode is sponsored by InfluxData. You stuck with slow, time series data queries? It's not your code, it's your database. Traditional databases weren't built for time-stamped data. InfluxDB was. Handle millions of data points per second, while competitors wait for dashboards to load. When you use the right tool for time series data, everything becomes faster, simpler, and more effective. Stop waiting. Start building at influxdata.com/realpython. Hey there. I've got a quick request. We've created our first Real Python podcast listener survey. We're trying to learn more about you, our audience, and what you're interested in us covering on the show. It's a quick survey, less than 5 minutes. You can click the link right in the show notes on your podcast player, or visit realpython.com/podcast, and the link will be in the show notes for this episode. Thanks. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Travis, welcome to the show.
Hey, thanks, Christopher. It's great to be here.
Yeah, I'm very excited to talk to you. Partly why we are connecting is the Python documentary, which is coming out here in August, and you're in it.
It's kind of exciting. Yeah, I heard about this project and I was really thrilled because I know people like to watch videos on YouTube. My kids are all doing that. And it's really helpful to have a video discussion of the rise of Python, just to help people understand. Python is so abundantly rich in history, and because it's essentially an ecosystem and it's like a whole world, whole metaverse of activity going on. And so this documentary will barely scratch the surface, but even with the preview I've seen, and I haven't seen the documentary. I've only seen
the trailer.
The trailer. And then I talked about 3.5 hours and they were super good.
And that's all in there, right?
And that's all. Well, yeah, I'm sure. They'll take a few of it. It will be interesting to see what I say in the documentary, what they pick up on. But they talked to a lot of people, and I was already fascinated to see. Oh, they talked to where Guido was working when he created Python, and I'm in that documentary, and Guido was suggested to the documentary folks that they come talk to me, and I was grateful for that because there's a sort of a aspect of Python that almost like a tribe or I feel like an ambassador and sorts of a particular culture into the Python ecosystem. And everyone's been so welcoming in the Python ecosystem and interested in learning, but it is a challenge because a lot of times the ecosystems, the people that I tend to represent or know about, and I'm like doing a lot of work to even understand that because it's big. Even the people that I'm representing is huge and diverse and lots of different voices. It's not like one voice. It's like lots of them. And you're trying to come and it's almost you feel like the EU ambassador or something. You're representing all of these countries to and you're coming and you're talking to
the United Nations of Python.
Exactly. United Nations of Python. That's actually, I think, the right way to think about it is you have all these people and it can be challenging because you're integrating so many views. And so that's what I try to represent is a little bit of that the lessons learned and the history and how some of the things I was aware of, knowing that there's stories even in that context that I'm not aware of. But I have been around a long time now. I mean, a little gray in my beard.
Yeah, me too.
But it's still, it still feels young. I still feel young. And I was very young when I got started in the Python ecosystem. I guess I was still in my late 20s, so I wasn't that young.
Yeah.
But it's been, it's for the past 28, almost 30 years, I've been, essentially engaging with the Python ecosystem, and it's been awesome, right? And and different kinds of things. I was very coding or very organizing and now I do a lot of company organization and hiring and trying to figure out how to, still my passion there is just to figure out to make open source sustainable. I really want to enable more people who want to do open source to be able to do it as a career, as a job, and not just only in their spare time.
Yeah.
But that comes with challenges too. So we can get into all of that. But that's kind of, it was the documentary that brought us together. And of course, I've seen you before at PyCons, Christopher, and I know about the podcast. And I think it's great. I think what you do to just get the word out, talk to all the interesting people that are in the ecosystem and the community.
Yeah.
It is a community, but it's bigger than a community. It's lots of intersecting communities. So, and mainly because if you're in it, you can sometimes nowadays you can be alone. It can be hard to understand. You're this massive world.
Yeah.
If I go to a foreign country, I'm alone. But the good news is there's actually all kinds of little outlets and shops and hangout places. There's just literally thousands of them, tens of thousands of places you can actually get involved.
I always want people to share them with me because I feel like they're underexposed sometimes, and you can feel rather lonely as a developer. Yeah.
Yeah, they are. And especially, the past 5 years, some of the, and sometimes just getting the word out, knowing about the people in your area. But what I've found awesome actually about the Python ecosystem is you being able to travel all over the world and meet people who you have some affinity with, right?
Yeah.
You have some common ground. Hey, we know the same language and we have some of the same feelings of that language. One of the things I thought was funny, and really about 4 or 5 years into using Python, you started to use, I love using Python. That's weird. Why do I love programming?
It's not always a common thing that happens.
It's not a common thing, right?
Yeah, in programming.
Why do I love this? And trying to back out why. And the unique thing was other people said the same thing.
Yeah.
Right? I wasn't just I'm not completely crazy. I'm just only partially crazy, but at least other people are crazy with me. What's going on? Right?
We're all crazy together. Yeah.
We're all crazy together. So it was, that was fascinating, right? Because, my journey into open source is very similar was very correlated with my journey into Python. So the two were quite coupled, basically.
Well, I definitely want to talk to you about that because that's been a common theme that I have covered with a few different people of how did you actually get involved in open source and in contributing and building things? And you obviously are taking this to the other level of thinking about true sustainability of how things can be a company and continue to provide these resources and tools. And we definitely seen a lot of that. I have a conversation with Maria from PyPI about ownership of repositories and this whole trouble of well, how do you have an organization and stuff like that? So cool. How did you get started with open source then?
Totally great topic. I can definitely talk about this for hours. So I got started as a graduate student.
Okay.
So I was one of the people that kind of went to school for a long time, mainly because I loved it and I loved learning, and I kind of delayed getting a job, in some sense. And I had the opportunity to, which is,
that's always good.
So I took the opportunity to go to school for a long time, but I also got married young. And those two kind of are coupled because I got married young and started having children young. And I'm also involved in open source. And so those two there's some conflicts there because time spent in open source.
Time constraints. Yeah.
Time constraints, monetary constraints.
Yeah.
Now, I came from a family that was, hardworking, but not very well off financially. So I was used to kind of not having much. So that was helpful because then I wasn't so worried about having, I didn't need that much. I had enough for my needs. I could actually work on things.
Yeah.
I was very driven by science, very driven by math, very driven by understanding the world. And programming had been, since I was young, a tool I would use to get stuff done, almost like an extended calculator. And I learned to program in Pascal originally, actually BASIC originally, then Pascal. My first computer was a Timex Sinclair, and then I did some work on a TI 49A, and then finally got an IBM PC compatible when I was in high school. And I learned to program Pascal. And then in college, I learned some C. And I came to Python as a grad. I was getting my PhD. It was after, I did some Perl as a master's student. This is back in the 90s.
Was this a computer science degree, or what was it?
No, I got a degree in electrical engineering. And applied, really, the focus area of my interest was signal processing and electromagnetics. So electromagnetic theory, signal processing, applied probability theory. And then for graduate work, I went to the Mayo Clinic and studied biomedical engineering, biomedical imaging, MRI and ultrasound. So, and that's what I was doing when I came across Python. I was processing huge amounts of, that wasn't that big by today's standards, but at the time it was large, and it made it difficult for the computers of the day to take, it was less than a gigabyte, but probably half a gigabyte of medical imaging data. MRI, ultrasound, and I got into a particular technique to combine motion and MRI.
Oh, cool.
So I was studying that, and I was doing a lot of algorithmic manipulation of data to try to produce the images. And I wanted to be able to, I could code in C, but it was tedious to do everything in C. It was like, okay, the algorithms were fine.
We leave that fun part we were just talking about.
Right, exactly. That wasn't so fun. It was like, okay, this tedious action of, and maybe that's why when I came to Python, I went, oh, now finally I'm not doing all this tedious work, and I'm not having to set types everywhere. And it just felt nice. And 97 was when I started using Python. And then for that year, I came in 98. I'd been using it off and on for about a year for tools. But I remember going back to a code I'd written a year previously and looking at the code and going, oh, I can still read this.
Nice.
Even though I wasn't like an expert, I could still see, oh, I know what I was doing.
Right.
I had the opposite experience with Perl in 95, 96. I'd been using Perl, wrote a bit of stuff, came back to it, and looked, I don't know what I said. I don't know what this is. This is like some arcane syntax. And not that you can't write obfuscated code in Python, you can. But
Perl is the regex language.
It's the regex language, exactly. And if I write regex code in Python, I have the same experience. Actually. So, but I was like, I liked it. This is interesting. And so I started to just go, oh, hey, I need some extra tools here. So I was scouring that for tools. I said, I need some extra tools. I need an ordinary differential equation solver. I need an optimization. And so I was just using search tools to try to find things. And I came across the mailing list. Back in the day, we didn't have GitHub, we didn't have Discord, and in some sense it was easier because there was one place. You went to a single place and there was a mailing list and you emailed that list. And then now there were several, because there was the Python list and there was a matrix SIG, special interest groups. And so I was emailing this matrix SIG, and basically there was a lot of conversations we had with, just all of a sudden I sent emails out and I could read all these threads and I was engaging with people. And it was like, oh, this is fun. There's people who care about some of the things that I care about. We can talk about it. And so that, and numeric Python existed. It was already an extension module, so I could do array math. I could do things. So I started to like that, use it. And then I started to say, I have some stuff I need. Let me write that stuff. And hey, I did this because of other people's code. Well, let me just share the code I've written. And so I just made a silly web page and put the code I had done. And I tried to package it into finite chunks, into like usable things. Like the very first thing I wrote was a reader for medical imaging data, and something that could read data and pull it directly into a numeric array. Because one of the things with Python is it's very high level, but if you just use lists and dictionaries, the raw data is boxed. The raw data of the numbers you're caring about have all this other stuff around it. Have,
the whole everything is an object in Python.
An object
thing.
And that's fine for a few thousand objects, but when you start talking about a few million or a few billion objects, now it's too much overhead. And I just want to race through a bunch of data and do math on it. So we needed the array data structure, which basically had all the data raw, and then put that extra stuff, just a little bit of the extra stuff per array. Right. And so most of the data is all raw. Well, that's great, but now you have to have libraries to do something with that. Like, well, how do you add those? How do you look at those? Like, all the libraries to do stuff on that kind of data structure has to be written. Now, Python makes it straightforward to build extensions, and you could build an array object. You don't have to only use lists and dictionaries, although they're wonderful. You can actually extend it. And there was an array object. We couldn't do math on it. So the numeric array, which became NumPy then. And so that my journey got started writing tools for scientific users to use Python as a steering language for their low-level data, the low-level code. Right. And so people thought, oh, Python's too slow. Well, what, for steering things, who cares? Like, all my hardcore math is still being written and done in a compiled language. So C, Fortran. and I was still using Fortran too. There's Fortran libraries that I would, this Fortran library does a great job of ordinate differential equation solutions or optimization or integration. So about 98 and all the way until about 99. So about for 2 years, I started just make a bunch of libraries, and I was just kind of scratching my own itch. Kind of, I need this. Well, I'll share it.
Okay.
And then what happened is during that time, so I was committed to solving my own problem.
Yeah.
And then just committed to sharing because people had shared with me. And so I'm sharing, and then all of a sudden people are responding and going, oh, hey, here's something you could do. And I'm like, oh, this is cool. I'm used to writing papers that nobody listens to or reads.
Yeah, they kind of get filed away.
Yeah. Now I'm engaging. And so that, it really, really was this kind of, I like this. I like engaging with people and then getting feedback. And I just fell in love with that activity. And so that was back in 99. And so then I, for the past 7 years, that's kind of been a root motivation. So I just started to do that. Eventually those libraries came out in a multi-pack. Then I met some other people. They said, hey, why don't we organize this into something called SciPy?
Yeah.
And SciPy was released in 2001. And then both a library and a conference and a community. We kind of had this sub community called the SciPy community inside of the Python community. And then that community was fantastic and still is fantastic. SciPy, the conference is going on as we're recording this in Tacoma, but it's come out later, I know. But that was sort of you found people to associate with. And then I just started to release stuff, that I cared about. One of the key things was not being everybody has the imposter syndrome feeling, right? Because everything I release, it's not perfect. Like, in fact, now I can go back and look, this is a problem. We did this wrong. But I was astonished maybe that like 99% of the feedback was positive. Yeah, there were a few times I got people that said stuff that was kind of like, oh, this is dumb, but it was actually remarkably small, right? Most of the interaction had been people just appreciating and then providing good feedback. And then the best feedback was when people would take it and then maybe do something else. Maybe inspired what you did, but did something else that was even better. And you're like, oh, that's cool.
Yeah.
And then you're sort of just part of this ecosystem of sharing. So that's how I got involved. And then
that's awesome.
It probably delayed my graduation a little bit, maybe 6 months to a year.
Yeah.
Don't tell my wife. No, she knows. But I had kids at the time. And so that's how I was already doing this. I had kids and I knew I had to get through school and get a job. And so that kind of put pressure on me to think about, well, what do I do with this?
Yeah.
I love this open source engagement, but what am I going to do to support my family?
Yeah.
And that led me to start thinking about like entrepreneurship early.
Yeah.
Now it wasn't like 10 years. It was 10 years later before I did anything about it. But that's kind of, with me, it was like the open source participation, thoughts about how to make it sustainable were kind of all tied together. And I read voraciously about economics and about IP and about all that stuff. But I found in the Python community just so much surface area for engagement with people in a way that was meaningful and I could learn from and then they receive from, that it just addicted me, just hooked me.
Can I ask you, I want to drill it back into a bunch of things, if you're okay with it.
Sure.
Very early on, you mentioned Numeric Python.
Yeah.
And I'm not sure if that was a project that was outside of NumPy?
It is. In fact, the word NumPy was being used inside that Numeric Python ecosystem by Paul Dubois. Had actually, there was a NumPy module in Numeric Python. But in 94, in the Matrix SIG, a few people, like Jim Fulton, basically had released he just put out a matrix.py file.
Okay.
He's a little embarrassed about this because but Jim, you inspired a bunch of people. Like, you put this matrix.py file out.
Yeah.
And it was just a Python only file, but people went, oh yeah, we need a matrix object. We need something we can deal with. That we use math on.
Yeah.
Because the array objects that we had in Python weren't good enough. They couldn't do that. But he kind of, okay, well, what if it looked like this? He wrote the Python version. Well, there's a grad student, Jim Huguenin, in 95 at MIT, who went, oh, that's a good idea. Well, let me code this in C.
Yeah.
And he basically wrote numeric, and inspired by J, inspired by other libraries that are out there. And he wrote numeric Python called numeric, and it was a C library that extended Python to create a multidimensional array object.
Okay.
It had a C library, then it had these things called universal functions that then could do math on the arrays. So you could add them, you could do sign, you could do computation on the arrays. And that's what he released that. And then he also added FFTs and a little bit of linear algebra. And numeric Python was released about 95.
Okay.
right? I came to the community in 97 because Numeric existed.
Yeah, you started to see these tools available.
Yeah, because otherwise I needed a tool that I could do math on arrays, because that's what I was trying to do.
Yeah.
And if Numeric hadn't existed, I would not have been, I was motivated, but not that motivated, right?
Okay.
I had to come to a place where Numeric existed and I could generate extensions that used it.
Yeah.
So that's what I did. Like SciPy came out of, oh, I see. We need these other tools added. Well, I can add new tools to a thing that already exists.
Right.
But Jim Huguenin did a tremendous amount of lifting. And then Conrad Hinson jumped in because he had been there for a while helping Guido add complex numbers. And as Numeric Python got written, the great thing was the Python community, and Guido is not a math science guy. He's a computer science and data structures and languages person. He appreciates the sciences and was willing to accept recommendations from someone like Conrad Hinson. I look at Conrad Hinson and think he was incredibly impactful. And he's still active, and he's a researcher in France, and there were people like this that were incredibly impactful.
Yeah.
Jim Huguenin and then Paul Dubois came in as someone who would kind of, I've done this before in Eiffel and Basel. Let me help organize. And that's the community I joined, where these people, they're having these conversations. And I went, these are great people. They're smart. They're capable. Python had already done some things like the language Python had changed sufficiently so someone like me as a scientist and engineer wasn't put off by it.
Yeah.
Right. And there's important things like, complex numbers are supported. Right. And that's a conversation I've seen it in other languages like Lua. Lua doesn't have complex numbers defined. Right. And like, okay, sure, it's just an implementation detail of two floats, but like that's really computer sciencey of you, right? To think about
it being
how do I do that?
The language, yeah.
Embedded in the language, because you're right. It's all I need is Lisp, and I can do everything I need, right? It's like you're right. Theoretically, I don't need much, but practically, as a user, I need it closer to me. I need it closer to what I'm used to.
Let me guess. Your time series queries start fast, then begin to crawl as data grows. Traditional databases weren't built for timestamp data like metrics, events, or sensor readings. They crash on high-volume writes and time-based queries. InfluxDB was purpose-built for this. Millions of data points per second, automatic compression, sub-10 millisecond queries. It's like choosing the right Python data structure. Using a list when you need a set works, but it's not optimal. Time series data deserves a time series database. Visit influxdata.com/realpython. The other thing I was thinking about is you mentioned this idea of looking at the language and being excited by Python because of how readable it is and how you can kind of approach it.
Yeah.
But what it was doing with these other tools is almost like traffic control. Like it's not doing the crunching part. It's doing like, this may be slow, but that's okay because I'm sending it to this fast zone over here and running everything around. Yeah,
exactly. Yeah. So kind of the idea of Python slow is a red herring. It's like, you're misunderstanding.
Yeah, it's fast to write in and fast to conceive of it. And I can think of it.
Conceive. I can iterate quickly in stitching together these libraries.
Yeah,
because the hard work is being done by these other codes.
Yeah,
and now fast forward, and we've actually gone a little farther because now Python is actually steering compilers. Right before it was just steering blocks of native code. Now you've actually got you got lots of these tools. One of the things I got involved with about 13 years ago was creating a compiler for Python called Numba.
Oh yeah.
Right.
Okay.
And now there's like 20 of them. There's 20 of them that do the same kind of thing.
It's JIT
different
sort of idea.
It's JIT kind of idea, but it's different than. And it kind of illustrates kind of the scientific group person who's thinking about using Python to steer native code. Thinks about compiling differently than like the people that created PyPy. Or the people that created. Okay, I want to have a theoretical compiler for all of Python. Like I've never been really interested in that problem in the sense of
sure.
I don't. I think the interpreter that's doing the the big while loop that's doing case statements about how it's blocking things. You could compile that if you want, but it's fine. I'm fine with what it's doing.
Yeah.
What I want is a way to not have to reach down and write C all the time.
Right.
Or a way, but so I've been fine with a compiler for a subset of the language for a long time. Just the one that spells. So, a user who's using Python and they go, oh, I'd really like this to be faster. Okay. Can you make a few changes? Like, okay, maybe set a few things. Okay, this is going to be typed, just add a few guides to the code and then compile it.
Yeah. That's how I feel about like types in general. Like the main reason you need them is when you are interfacing with other languages, other pieces and stuff like that. I always thought of it as a web, or I was a database guy. And so it's like, okay, well, if you want your web stuff to talk to the database, it's really good if they can agree on what they're talking about. And I could see the same thing in this scientific community of like, we got to make sure these numbers are going to, stay the same types and so forth. And
well, you have to be able to distinguish between, this code path, the computer does something very different when you have a floating point or a complex number or a string or an integer. It does something very different.
Yeah.
So you have to, at some level, I'm actually using a different block of code to execute on this at the very lowest level, right? So type systems are like this traffic cop, right?
Yeah, exactly.
But Python was doing that too. And so I was actually really thrilled to see the optional typing as it came into Python.
Yeah.
But once that came in, that's actually what motivated me to go, wait, we should use that. Even though that wasn't the primary motivation, I see types. There's two big motivations for types. One is something I care about a lot, which is making it possible to compile fast code.
Sure.
Right. Once you add types, or at least understand the types, you can compile this code. And it can be as fast as, that's all C's doing. That's all Fortran's doing. No, nobody's writing assembly code anymore. You're writing a high-level language. There's no reason with a data type information, Python can't be that compiled high-level language, or at least something that looks like Python. Maybe not Python, the whole language with all of its dynamic, not the whole thing, but a subset. A subset, absolutely. Numba was one of the first things that did that. It's sort of distinct from. I remember when I gave talks at PyCon about Numba. I had to kind of separate it from the unladen swallow or the SciPy or the people going, wait, this is what they think about a compiler. It's like, no, I'm really just compiling a subset so that a domain, a scientist who's used to Python doesn't have to reach to C. They could actually just keep C's in Python. Now, that's Numba's still active and Numba's still a very powerful tool. But then there's also, the PyTorch ecosystem, the JAX ecosystem, all the machine learning ecosystems. Like there's compilers all over the place, actually, in that ecosystem. It really is exploded. I mean, you can go to, there's lpython.org. You go to lpython.org. It's a example of a compiler for a subset of Python, but he's got a list of like 40 or 50 compiler projects in Python.
Lots of people,
it's crazy, right? Lots of people scratching their own itch.
Yeah.
But I like that because Su Quan Lam, who was really the guy that made Numba work. Like I started the Numba project, but really the best thing I did was hire Su and then figure out a way to keep paying him.
Yeah.
And that's kind of what led to why these days what I try to do is figure out how to find money and tie it to great people, and so that people can spend their time doing great things. That's mostly what I do today, is actually just fund open source. But I still have a lot of these perspectives because for a long time I was just in the weeds doing this work myself and trying to figure out how am I going to pay for this, So there's still areas where I have a lot of perspective. And so compilers in Python is definitely one of those areas now where I have a lot of perspective.
Yeah, you've seen the early stages.
Seen the early stuff, right? Yeah. But the other reason for types is actually unrelated to compiling. It's just about coordinating code with groups of people.
Yeah, different. Like you're moving things from system to system.
You're moving things from system to system. So what we definitely saw, like, I love the fact that I didn't have to specify types in Python. That's why, as a scientist, I loved the language. I wasn't like bogged down with all this type stuff.
Right.
And I could explore and experiment really quickly. Okay, if you get a group of people like 10, 50, 100, 1,000, because now Python's been adopted these large organizations with thousands of developers.
Yeah.
And now you're essentially all contributing to a common code base. It can be really, really challenging if you don't have types to guide you through that.
Yeah.
So now, because now you're encountering code you didn't write, but somebody else did, and you go, okay, how do I understand this code? And if the only way I can understand it is the documentation or runtime, like types are essentially a scaffolding to help large teams interact with large code bases.
Yeah.
That's actually what convinced Guido to do more work in the optional typing area, was that when he saw that at Dropbox.
To look at MyPy, creating that?
Yeah, well, the MyPy stuff and the optional typing, he got religion about that because of his work with a large team at Dropbox trying to manage a large Python code base. You start realizing, oh, there are some things here where, and not that, he probably thought of it before. I don't want to speak for Guido, but I know that's definitely correlated with when that jump came into the language. And I had the same experience. Like I watched Python get deployed at JP Morgan and Bank of America and these large people, and they're kind of stumbling on each other a little bit. If there isn't some optional typing when you start to manage and maintain a large library. So I'm kind of the opinion that, like, as a code base gets more mature, you need to add typing to it.
And that's where I see it used, right? I mean, the mistake that a lot of people make in teaching Python is trying to teach it all at once. Yeah. And it's like, no, just start using it and building it and creating it. But if you're going to make a package or you're going to make tools that interact with other tools, and that's where you start to look at it.
Yes.
I feel like this emphasis is like flipped. In C, you have to have that stuff.
Yes.
It won't work yet. And so like Python, just start using it, build it, and create with it. And I feel like that's
very well said.
Gets lost occasionally. And
no, it's beautifully said, actually, because that's the reason Python's so engaging and you love it, is because it doesn't get in your way. It lets you enter the pool of a large code base softly.
Yeah.
You don't have to be thrown to the deep end. You can actually just wade in. And as you wade in, you find, oh, there is support for me to go as deep as I want.
Yes.
And especially now that Python has these compiler tools, you can go as deep as you want. Like, you can write optimal code with Python syntax using tools like Numba or PyTorch or JAX.
Yeah.
Like, it's Python, well, but not really, because this part is actually being compiled by this subset. and you can actually, people like, there are people out there that have made amazing examples. Like, you can really, shoot your leg off, to use a phrase from one of our early contributors, Dave Beasley. But anyway, it really is. I think the main thing is to help is Python had this fit this needle of really focused on the user engagement and the human engagement.
Yeah.
One of the things I'm curious about, and I'm interested to see over the next 5 years, is how does the growth of AI programming alter the surface of Python engagement? Right? Because one of the reasons Python was so in demand and grew so quickly is because you didn't have to be a programmer to be a Python user.
Right.
And for a long time,
you could be an office worker looking at ways to automate things or what have you.
You could be a office worker, a database administrator. There's
had chemists on last week talking about coding for chemists.
Yes. Yes, exactly. A scientist of all kinds. Yeah. And previously, like, oh, you got to know types and pointers, and like, that's a lot to keep in your head, right? But if you can just functions.
All right, here we're going to break out Pascal and C and
C and Java, like, and it also is great for new people to computing, I think, because of the same reason. Like, I actually don't hate Java. I think Java has a place. It's a good language for what it does.
Right.
But it's the wrong language to teach new people.
Yes.
Like, you should not be teaching new people Java. Like, it's like, and there's a very simple reason. It's what you described.
Yeah.
It's like Java forces you to write classes from day one.
Yeah. Yeah. The Hello World example is
World.
Yeah.
Is you have to write a class. Like, and my view is, like, writing classes is actually a more, like, it's at least intermediate, if not advanced, computing use case, because what you're doing when you write a class is you are creating an abstraction, right? And creating an abstraction for other people to deal with, it shouldn't be taken lightly. Because
it's like you're really getting into computer science at that point, and the idea of, like, lifting up above stuff, and it's like, it's great to know that that's what's happening underneath the covers in case you're that curious student. But so many other students want to see the lights start to blink or stuff to print or this thing to get automated. I wanted to see stuff happen.
Do stuff. Write some functions, use some data, use some other classes, use some data structures.
That was the story with the chemists. They were like, we're going to teach you a function. And then also they flipped it around. It's like, well, here is the problem, and then solving it, which is the reason I'm here. It's like, I just want,
is that right?
I love solving problems, mostly for other people. Like, I am that person who I like to fix other people's problems, and I'm like, oh, this is an awesome language to do that with, and quickly.
And you said that databases and data were probably, you also have music clearly as an interest. You ever mix your programming and music together?
I'm starting to play with some stuff. I'm learning more. But that was my problem with computers. I sadly to say, I had a scholarship to study electrical engineering at Arizona State University back in the 80s, and I hated it.
Yeah.
Because computers were kind of boring at the time, and I was addicted to music, and I dropped out and
it's pretty tedious.
Got in a band and toured and did all this different stuff, and I kind of came back.
Oh, that's cool.
And computers are fascinating now. Like they can do everything, which is really amazing. And not, Python didn't exist then, and I think I probably would have had a very different approach. If I would have been a few years later, maybe.
Yeah, so. Exactly. That's the value of it, and I am interested to see how that evolves as AI. But I'm of the firm belief that we still need languages for AI to generate.
Yeah.
Like AI is, what's it going to generate? Ones and zeros? No, it's going to generate things, human readable languages.
You need to look at what it's doing. Yeah.
Yeah. And so I think Python's still an amazing substrate for AI to produce.
Yeah.
Like code generators, like what is it going to generate? Why not Python? Because it's still a readable and accessible language.
Yeah.
So anyway.
The post I saw today that really threw me off was like, it's, kind of like a Jurassic Park kind of idea. Just because you can, should you? But one of the things that people are doing with AI tools is it allows you to generate code so fast.
It does.
It's like, okay, well, so everybody can build all these things, but the real trick is like actually supporting it. Making sure that it continues to run. There's a video game I'm very interested in right now, and every time they touch something, they break 7 other things.
Yeah.
And it's like, okay, well, like if you didn't create this code and you're fixing something for a customer or what have you, and suddenly you touch something and there's a cascade, and like, how are you going to do that? And it's like, I don't think AI is going to solve that yet. It's way better at generating things that exist, but it's not super great at like going inside the structure stuff and understanding what's happening. So it's going to be an interesting time. It's so easy to make stuff fast.
It is an interesting time. We have, correct. It is a bit of a danger where we actually need more expertise rather than less. And so my
different expertise, almost.
It's different expertise. So I want, I think about, I'm not an AI, like you got to stay away from AI or anything, but I am, I'm cautiously optimistic. I'm like, we still need lots of people to look at that code and look at it, review it, not just accept it. And so let's use it for a training mechanism. So how do we build expertise?
Yeah.
I'm a real believer in that open source communities are actually a fantastic way to build expertise over a long period of time.
Right. And there's like, it's almost the trade apprenticeship area of this stuff.
It is. It's like a bunch of guilds, a bunch of trade guilds out there, and that's what the cool thing about Python is. There's lots of them. There's lots of them.
I love that term. And I think that the term is used in a few different companies. I talked to Pablo a long time ago about his work at Bloomberg, and that they had guilds, and I was like, oh, that's really fascinating term to be using in this, but I feel like open source is sort of that, like,
it is.
Let's bring you up and look at it and share, and so cool. That it kind of takes us full circle back.
Full circle back to that's basically there's a series of guilds that I've been a part of, and one of the challenges in Python has been the fact that you've got this language that can support so many different kinds of people.
Yeah.
And then do we have enough representation in the core team, the core Python, the part of Python that moves it forward, like the steering committee, the packaging authorities, like the packaging world? Do we have enough representation from the guilds so that they're actually serving everybody instead of just, and this is a general problem with human organization. It's not like suddenly we've got this new problem. It's like, that's been a problem for a long time. We've fought wars and had all kinds of state problems over this. Fortunately,
there's always managers of sorts.
Exactly. There's always managers, but it remains an issue. And really what it needs is people that are the ambassadors, people that do that work. And that's why there's always opportunity in Python. Like sometimes I hear people say, oh, well, gosh, you did all this great work, but now there's nothing left to do. You've done, like, I wish I was back then and you could all. My answer to that is there is always something to do. There is always something.
Do you want to see my backlog of things I've been thinking about?
Exactly. There is an opportunity today, exactly the same as the opportunity was 30 years ago, just to maybe something a little bit different.
Yeah.
But to basically follow that recipe of have something you care about, share what you're working on, and then listen and engage with people that have similar interests that will naturally gather around what you care about.
Yeah.
Right. And then you engage, and then now you have even more facility for doing that. You have a PyCon. Back in that time, PyCon wasn't really well organized. There wasn't a place to gather. We had to create the SciPy conference. Right now, you have lots of meetups, conferences. It's kind of, maybe the problem is there's a surfeit of them.
Yeah.
You don't know where to go. Like, well, which one do I hang out with? In some sense, yeah. But if you care about what you're doing and you're just authentically showing up with people and sharing and then listening,
yeah.
So those are the characteristics that actually really help communities thrive: is caring, sharing, listening, right?
Yeah.
And there's a lot of that in the Python ecosystem.
In some order of that.
Don't tell me which is more important. I don't know. It varies. But people that are willing to do that, and particularly people that are willing to cross guild boundaries.
Yeah.
Because what can happen is, I'm a SciPy developer.
Yeah.
I'm a PyData guy. I'm a Pandas guy. Okay, cool. Are you willing to go talk to the other people that do things in the Python ecosystem?
Yeah.
And it is hard. I have to admit, it's hard. I mean, I did a bit of that when I was writing NumPy.
Okay.
Because part of NumPy was really a unification of libraries. It was coming together because I came in and Numeric existed.
Right.
Then another library called Numeric started to be written. And I saw a bifurcation that the two libraries didn't share data. They were like separate. All of a sudden, you're allocating memory separately, and they didn't share common libraries. And so
you could see some weird collisions if people use them together.
Exactly. Yeah. And so this isn't good because the end user just wants stuff to work. And so I took some time off of my teaching. I had a break, and I could say, well, I'm going to unify this space. And I wrote NumPy as a merger of NumPy and Numeric and Numeric.
Okay.
And so there's a lot of community building in that effort. There was code writing, but there's a lot of community building.
I could see people being concerned about their ownership stake and their legacy. Yeah,
absolutely. Now, in this particular case, Jim Huguenin, who is the original author of Numeric, had basically moved on a bit.
Okay.
He's like this prolific creative genius, essentially. And he'd written Numeric. Then he went to Microsoft and worked on the CLR. And then he went to Google and worked on Flutter, actually, Dart, and then, what's turned into Flutter.
Oh, wow.
So he kind of moved on away from this ecosystem, even though his legacy is continuing in what we're relying on and what we built and developed from. So that side was, and the Numeric had just gotten started, but that was exactly a lot of the work. A lot of the work was say, hey, come be a part of this new effort.
Yeah.
Oh, there's some great ideas here. Let me incorporate them. That's where a lot of what made NumPy work was. I was very interested in making it work and very willing to spend the time it needed to happen to make it work. But then I was very willing to listen to other points of view. In some cases, I needed some additional input. Like I made some really stupid mistakes in NumPy, like things that today I'm super embarrassed about. Like, oh, that was really dumb. Yeah, I should have done that differently. I wish I'd been smarter because I just wasn't. But some of the things that are there are a result of listening to other people. Other people said, oh, that's, here's what you can do.
Okay.
It's so critical. In fact, and then I got involved with Python itself because, we need to actually, originally NumPy was like, well, let's make NumPy part of Python. Let's make the multidimensional array a part of Python. Like replace the array object in Python with the multidimensional array and move Numeric into Python. That was going to be the kind of the way to unify the community, is to do that.
Yeah.
And I met with Guido and Paul Dubois. We had lunch in San Mateo, and before in 2005, roughly. So part of is just, I said, I got on a plane and I called up, I emailed Guido and said, hey, meet me for lunch. Would you do that? And he was so willing to do it. And he was so gracious, so willing to have
That's
conversations like this. So that was critical, right? Because he's like, it wasn't his baby. It wasn't his issue, but he was willing to listen and willing to help. And we didn't do that at the time, which is right. And Python 3 was in his mind. The Python 3 story was starting at that point.
He kept thinking about where that was headed.
And so part of this was, let's make this part of the Python 3 story. Is Python 3 will have this array object built in. And we briefly talked about that for, about an hour, right? But then the challenge was, okay, wait, they're going to have a release cycle that's 18 months. They were getting more mature in how they wanted to think about releasing Python.
Yeah.
And the challenge was that's not really going to work with this energy for at least 4 or 5 years, because we're going to need to iterate more quickly than that. We're going to need to iterate every 3 months.
Right.
It's just the maturity curves were different between those two efforts. And so it's it's not time to do that. But can we at least get the data structure in Python? And this is part of the fix it twice problem. We had this bifurcation between Numeric and Numeric. There's this concept of fix it twice. You fix the immediate problem, but also then the proximate problem. The proximate problem is there was not a way to share large data blocks in Python very well.
Okay.
They had a buffer protocol, but it wasn't very rich. Didn't have a rich data types around it.
Is this like having to deal with like literal, like, okay, is this a 16-bit, 32-bit type of structure?
Exactly. And so, for example, as a database person, it showed up there. Like the database API initially, and then finally they started to take advantage of what we did. It took a while, actually. But, you basically, my view, a database record, if you're taking a collection of records, the view return, you shouldn't box that all up into lists of dicts. You should actually return a pointer, an object that has all the data stored in its types.
Okay.
Right. But there's no way to describe that
until
we added the memory view object.
Okay.
We extended. So that's what I did. A few other things too, but the main contribution I did to Python itself was to add this structure of NumPy into Python itself in the extended buffer protocol and the memory view object. Now, to be fair, we did the standard buffer protocol. We got the beginnings of the memory view object, but then I was writing NumPy, and so the memory view object was pretty anemic itself, because I'm like, well, if I'm actually using, I'll use NumPy. I won't use this memory view object thing. I'll use NumPy. And so the memory view object basically sat there underdeveloped for about, I'm sure some people were pretty mad at me, because it's like, oh, wait, you kind of half finished this. But
back burner.
Yeah, exactly. But fortunately, Antoine Pentreau, Stefan Kra, there were a couple of key people that went and finished the memory view object.
Okay.
And then all of a sudden the database people could use it. And then we got to where I was hoping we'd get, there's projects like Arrow that now exist. Have you heard of the Arrow project?
Yeah.
So the memory view object is like in Python an Arrow equivalent.
Okay.
Right? Arrow basically was inspired by that to create something that worked cross language. Right. And so
stay in memory,
so you not have to convert and not to box it up either. Like, boxing, I mean, you don't have to put object wrappers around every little data structure, right? You can actually put one object wrapper around the whole memory block.
Yeah.
And that's just way more efficient, especially when you're talking about big amounts of memory.
Yeah, no, it's crazy. The amount of like dropping in, dropping out, dropping in, dropping out,
exactly.
Like conversion, it just was like, that's the slow, if you will.
That's the slow. That's just now getting to where it's not the problem, the bottleneck, but it took a long time to get there, actually, maybe just now, past 5-6 years.
Yeah.
But that is what ended up from those conversations. We ended up, and that's how I got involved as a Python developer. Huh. And so I had a commit bit to the Python repo for a while.
Okay.
Now I'm emeritus because but that took a lot of effort, actually. Some of the hardest conversations were with the Python developers who are super talented, knowledgeable about things that I was not as knowledgeable about. Like I'd not taken a computer science degree. I was not steeped in data structures and compilers and languages. And so they would bring up things and I was like, okay, I think I understand what you're saying here, but maybe this is the way I do it. I was proficient in writing C code and doing low level. I actually was an electrical engineer. I understood how computers worked. I understood assembly code. I understood all of that, but I didn't understand some of the, like, why do you care about this?
Okay.
Why is this an issue? Why is this something you're thinking about? I didn't have that.
Yeah.
If that makes sense.
That's a hard thing to tease out.
It is. So some of the hardest things for me was to be after that boundary, but it was, I think, some of the most valuable.
Right. Because you're using it now with all the skills that you have for building these like ideas of sustaining stuff. Yeah. Exactly.
But I would say, so anybody who is interested in contributing, recognize there's an opportunity to be like a guild participant, whatever your ecosystem is, and then to share that with a larger group, to kind of be an ambassador to the packaging community, to the core Python team. Like, and Nathaniel Smith is another one who did that later. And we were able to get the matrix multiply operator in Python because of his work. Conrad Hinson was one of these people early, right, who did this ambassadorship. But the fact that there's only a handful of people that have really done this a lot is part of the challenge. Is like, it's really super valuable. We need kind of more of it.
Yeah.
But it's also hard to motivate and it's hard to do.
This week, I want to shine a spotlight on another Real Python video course. And it's of interest to anyone starting a journey into data science and exploring NumPy. The course is titled NumPy Techniques and Practical Examples. It's based on a tutorial by Ian Eyre. And in the video course, my co-host, Christopher Trudeau, shows you how to create multi-dimensional arrays from data stored in files, how to identify and remove duplicate data from a NumPy array, how to use structured NumPy arrays and reconcile the differences between datasets, analyzing and charting specific parts of hierarchical data, and creating vectorized versions of your own functions. Throughout the course, you'll walk through several examples that'll show you how to use the techniques effectively. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com.
I'm actually, it's happening now. The companies are starting to invest significantly. NVIDIA, Meta, Microsoft.
I've been excited by it and been covering the whole, just having developers in residence and people to do other kind of backup stuff at PyPI, like Maria, who I interviewed recently.
Yeah.
So it's nice to see that hey, there are these positions, because the backlog is the thing that I think was making maybe some contributors, if they weren't directly talking to somebody, like, I have to wait how long to even see any kind of movement.
Yes.
And
yes.
Which is very anti-Python in the sense, like, hey, I can develop something and create something and see results quickly. And suddenly now I got the bottleneck of whatever you want to call it, organization or lack of
facilitation, there's a lot of opportunity to plug in. That's what led me. I mean, these days I really try to sponsor, help, grow, build. I still have things I care about. I have technical things I care about.
Yeah.
Particularly around compiling and packaging. Like how do we ship stuff to people and how do we compile better?
Yeah.
And we could talk, and I'm really interested in AI systems, and that area is still very fascinating to me. I do a lot of thinking and some coding, but mostly thinking and then hiring, organizing, product management kind of activity more than coding these days.
Yeah.
But it's really important that to fund that too.
Yes.
And so that's what I end up thinking a lot about, is because stemming from my early days, if I was working on this stuff, had 3 children, going, how am I going to do this? And so I got thinking about that. Eventually, that led me to leave academia.
You yourself were in the state of like, well, how can I sustain this thing I really love to do?
I was in the state, right? How am I going to sustain me? Right. And there's still an open question. It's like I've solved it or anything,
right.
But it's a rich problem space. I have a lot of ideas there. I mean, we could spend 3 hours talking about all the different ways that. And so if anybody is interested in that, I love to talk about this with people. If people are thinking about businesses that relate to open source, ping me or reach out. And I'd love to, in fact, I even got an incubator set up and a funds, like investment funds set up, so we can actually support people who are trying to be entrepreneurial in this space. So that's the direction I've gone in my career, is to how to actually create more ownership of activity, and then to share what I've understood or learned and learn with them, be more a collaborator, mentor. And then finally I got, because of the help of Ralph Gomers, Tanya Allard, and so many people at Quansight, PBC, Quansight Public Benefit Corporation.
I had Tanya on the show very early on.
Awesome. And I'm so thrilled to work with her. And I can finally say I was able to hire people to work on NumPy and SciPy.
Nice.
That was the whole reason I left academia to work in entrepreneurship, is to be able to do that. It took me a long time, actually.
To find the bodies that can do the stuff and pay them.
To find the money.
Yeah, the money to pay them.
Right? Find the business.
Find the positions and fund the positions.
Yeah, exactly. In a way that I could, legitimately say, yes, come work. And it's not going to be, because if I employ, if I'm like, okay, I'm going to hire you, work on it. I feel there's accountability. I got to make payroll. I got to make sure that the money is there to pay you every month. And getting that from investors and customers is not trivial. Like, there's actually a real thing there.
Yeah.
So that's what I spent more than I expected time doing that over the past 15 years.
And so maybe you can give people an idea of that organization. It's Quansight.
Yeah. So there's several organizations I'm a part of. I'll talk about, it's like OT Incubator.
Okay.
It was originally OpenTeams. We're kind of rebranding it as Open Technology Incubator.
Okay.
OTincubator.com. You can go there.
Yeah, I had heard the term OpenTeams when we met at PyCon.
Correct.
Yeah.
Correct. PyCon, we sponsored a big event. And one of those companies we incubated is called OpenTeams.
Okay.
What OpenTeams does is it helps people have sovereign AI and sovereign data. We want a world where people own their AI, own their data, and not just to kind of send their intelligence to a third party. We don't believe AI is SaaS. We believe AI is a system that the intelligence needs to come into. You need to absorb the intelligence in the systems there. So that's what OpenTeams AI focuses on. We help organizations own their own AI. It's almost like, great, you see what Perplexity, Anthropic, and all these companies are doing. Do that with your data.
Yeah.
Right. And it's possible, right? Especially with open source. So that's OpenTeams. Quansight is also another incubated company. Its focus is on helping large companies connect to open source communities effectively.
Okay.
So NVIDIA, Microsoft, Meta, Google, small companies, JP Morgan, Bank of America, all of them, they use open source heavily, but sometimes they don't know, how do I actually engage with this? So people have come up with, with a gig economy, let me have a code bounty system. I get that, and those are interesting, but the problem is open source developers are not gig developers.
No.
Like open source developers need to work someplace, right? And so what Quansight PBC does is create an entity that hires people that can work with the communities, and it focuses on being a community, being part of those communities, really participating in those communities, so they can then advise companies as how to engage with community-driven software. And so then we do project work that we call them community work orders. We do grants, we do contract work to basically, but doing that. And there's several example projects I could talk about. Like, for example, the CPython work that Microsoft did, love what they did.
Yeah.
But in some ways, it would have been awesome if they would have contracted with a third party, so that, because a company has their business to run, and they need to, and it's a real issue, and they need, and they can sponsor open source,
right? But
creating a developer ecosystem, so kind of as you build developers, so NVIDIA is doing this right now, they're hiring great people to work in the open source. We help them, some of this you probably ought to just use a vendor to help you, because what Quansight PBC focuses on is hiring a team of engineers that knows how and is authentically engaged with open source communities. And that's its whole purpose. Its whole purpose is doesn't have any other product agenda, doesn't have anything it's trying to do. It's literally just trying to make sure open source grows and these communities grow. And then the money to do that is coming from companies that want help. And either they do it themselves, it's like, they'd have to do it themselves, or they can actually do it together. If you're going to only hire one open source contributor in your organization, they're going to be alone. Don't do that. Contract with somebody. If you're going to hire 3 to 4, okay, maybe you can. Good, do it. Right. But then you might also want the help of a company like Quansight to help you engage with the community well.
I can imagine there's like a 1,000 like things that those open source developers like have to think about. Like, and these are problems that have been run over probably, hundreds of times by you guys. Like, so you have the experience, like you have the guild, if you will, behind it to say, hey, yes, we've experienced this before. This is how you handle this. This is like licensing. This is all that stuff.
There's the missionary mercenary problem too. One thing that happens once you start adding money into an open source community is you have the problem of, wait, you're getting paid, I'm not getting paid. This is unjust. This is unfair. Like, you have this problem, right? Which is absolutely true. Then you also have the problem of corporate capture of the community. You have the problem of the corporation has agenda, which is fine, but the community needs to support a lot of agendas, not just this one agenda. So how do you make sure the community isn't just captured?
Where is the boundary line there? Yeah.
And the whole reason I created NumFOCUS with early friends in 2011 was because I was also creating Anaconda.
Okay.
And I wanted to make sure that the work we were doing, that it wasn't automatically just a part of the corporate entity, that there was a place to organize community-driven code, community-driven activity, right?
Yeah.
And then and that's why Quansight is a company, but its whole focus is community-centric. It's to promote community-driven software, and then it helps companies connect to it.
It's very different. I think this is different from TideLift.
It's very different. Yeah, very, very different.
Yeah, that was more the one you were talking about.
TideLift, and I know those guys, and I like those guys, but it's different. Quansight is more about okay, you want to hire a developer in residence. Well, who would pay them? Where do they work, actually?
Yeah.
Like they could work at Quansight, right? And you could actually hire a developer in residence by using one of the people at Quansight.
Okay.
Because that's their long-term home. They have a place. They get benefits and W-2s, and their long-term home. They have a career that could they could be there for 5-10 years, rather than just 6 months. It's not a gig. It's not a gig mentality. It's like So that's what Quansight does, and really love it. Love it. We were able to create this, kind of carve out this sort of story that's been doing a lot of great work, and want to make sure that continues. And then the incubator is about helping create other companies, and then a venture funds, so we can invest in 100 companies that are, because there's lots of different patterns that can work to make open source sustainable. And then I do have this little project that's in hibernation right now, but FairOSS.org. I haven't mentioned it for a while because it's still on my mind, but I'm like, I got to fund this better before I actually push more energy into it, because it needs more. It'll need like a sustaining energy of funding to make it go for 10 years.
Okay.
And it's about connecting every company to the economics of, I want to make open source tradable. I want to make investors able to invest directly in open source and create instruments that tie that to the value of economies that are growing. So we have an idea about how that can work.
That's really intriguing. Yeah. No, what's the name again?
I think it's called FairOSS.org.
Okay.
And there's a website there, but it's been a couple of years since. It's still active in the sense there's still contracts, there's still things we're working on, but I'm not pushing it very hard right now. But I expect to maybe within the next year. I'm just, because I need to find leadership. I need to find funding. So these days, what I look for are entrepreneurial-minded people who want to create in this space.
Yeah.
People like Tanya Rolfe, people like Joe Merrill, people like Brad and Blair, who I partnered with on Incubator, and then funding sources.
Yeah.
Including investors and people that are like-minded that want to put money into these key, what I consider to be really key engagement models of how do we scale the cooperative model and the ownership model that shows up in open source, use it, and then add to it the incredible ability to serve people through companies, through building products and services that people can buy freely and they can choose what they buy and don't buy, and make it a world. I don't want to see when organizations get too big.
Yeah.
Like we need a world with a lot of organizations, not a few tiny, a few huge ones.
Yeah, no, I always joke with this with my friends that, you read the news, you look at things, and I grew up, Alien, the movie came out, and I had this idea of this like corporations literally owning all these, literally all aspects of life, and I don't want that either.
Right? No, exactly. And to me, it's the democratization, the decentralization, the fact that, and this is where the ethos of open source is a enablement to that, because it really is.
Right.
It's at the end of the day, when you have distributed ownership, people have to come to the table to voluntarily work with each other.
Right.
Like, because you just, it's sometimes more efficient to have a top down, no, I'm going to say, and you do what I say. That can be more efficient at times,
right,
but it's not as stable, nor is it as serving. It doesn't serve as many people because you don't incorporate the knowledge of as many people.
And a lot of people don't want to join that because they're joining always at the bottom.
Exactly. So I like to help people see patterns. So, in my mind, like, look, take a look at what we did at Quansight BBC. One of the things I did with the venture fund, for example, is the venture fund has carried interest. And if you look in the venture fund, see how they work. Oh, this is how the carried interest goes to the owners. Well, in our case, a portion of the carried interest supports the lab, supports the open source research lab. Like, there's a direct relationship. And we kind of have a model there for how any open source research lab could be supported by some of the carried interest of a venture fund. So these patterns of how you actually create transactions and business incentives and alignments to enable open source to thrive, that's what I get excited about. I need, at this point, I've been over the past 6 years just embedded in operations of getting a few companies off the ground. After Anaconda, which I founded in 2012, when I left it in 2018, I'm kind of like, how do I do this again? How do I do this more scalably? How do I do this, not just me, but how do I help other people do it? Like,
right.
That's actually what I want to do, is help other people create.
Have you spent time, like, I'm sure a ton of it's in your head, but this idea of like, well, what are the lessons I've learned by starting a thing like Anaconda? And it's like this huge list.
100%.
Yeah.
It's a huge list. And that's actually, I need to start figuring out, I'm trying to think, okay, how do I actually get some of this out? Maybe I need to probably write a little more.
If you're interested, like, I think there's two things that we discussed in this, like the SciPy history would be an interesting thing to talk about. Mm-hmm. And then the Anaconda history would be an interesting thing to talk about too.
Happy to.
I like having these conversations because I think it would be useful, again, as a model for like,
yes,
good, bad, whatever.
That's the reason it's valuable to talk about. It's like, because I actually don't love the spotlight.
There's so much lost history out there, like, in some ways.
The only reason I'm willing to, because it's lost history. Like, I want people to learn. It's not, somebody told me once, like, if you don't write down what you learn, you're like throwing away most of your experiences.
Yeah.
And from my perspective, it's like, okay, it's hey, maybe you can learn from this. Like, hey, because I'm like, I loved that. I loved when I had information from other people they were willing to share that helped me in my journey. And that's what I'm trying to get back to.
Yeah. I mean, why do people listen to podcasts?
Right.
Stories and things,
Right. And there's a lot of information here that I'm like, okay, yeah, that's the only reason I want to. I'm kind of, I love my family. I love the people close to me. I love meeting people and engaging people, but I actually don't like the fame part of it, or the perception of the only thing I appreciate is I like people.
Anybody who's super interested in that is kind of an odd duck. Yeah.
It is. It's like, I like the people, but I'm like, oh, why? Who cares what I did other than learn from it? Like if I did something that you can look at and say, that was stupid, that was good, awesome. Like that's what I hope you can take away is.
Yeah, awesome.
Because that's the value is the 100 people or the 1,000 people, the 10,000 people that do things a little bit better off of the mistake I made. Cool. Like, so that's what's worth sharing.
Let's move things forward.
Let's move things forward. Let's not repeat the same mistakes, right?
Yeah, there's so much regression that's happening currently.
There is a bit of regression happening. That's why I feel like, some of the lessons of community sharing and the community we're not paying attention. We're going to revisit them. But I guess that's the nature of history, right? If you read history, it's like, oh, we kind of do this again and again, don't we?
You can be a little more selective though.
Be a little more selective. So I'm interested in the conversation. I'm interested to talk to anybody who cares about open source, who cares about community-driven open source, who cares about entrepreneurship, especially sustainable funding of those things.
Yeah.
And I've just got so much benefit from the rich ecosystem of Python, the rich engagement with all of it.
Yeah, yeah.
That I feel a need to give back, basically. So
that's cool.
Yeah.
Yeah. Well, I like to ask these questions. Everybody comes on the show. The first is, what are you excited about in the world of Python right now?
Yeah, so I'm really excited about compiling Python.
Yeah.
Right. So kind of the next, I've got a few things in my head. I actually call it post Python, performance optimized statically typed Python. It's kind of a little bit play on words.
Oh, okay.
I've got a little, which is kind of a pattern. Numba would be considered a pattern in that space. It's like a specification. I want to create more of a specification of what it means to be this. You can have multiple implementations of it because basically it's showing up in JAX and PyTorch and Numba and Codon and a few other languages. But can we specify it? Can we give it a little more heart? This is what it means to do this.
Yeah.
So I'm interested in that, and I'm also interested in free threading Python. Actually, the free threading stuff. My friends at Quansight have been, with support from Meta, have been doing this. The work of they got No Gil in was phenomenal, and actually, it's really, really important for certain problems that you have this availability.
Yes.
Like some, it's not going to be a big deal, but there's a lot of really interesting things happening in that space. And the nice thing is actually beyond just that implementation. My friend Eric Snow has the multiple interpreters approach to parallelism. Well, actually, a lot of the work that's happening in the free threading world also is important for that work too. So it actually is just it's helping the whole parallelism story,
lifting everything up.
So I'm excited by that. There's a lot of energy there, and it's really interesting to see what's coming out of that.
Yeah, cool. The next one is, again, doesn't have to be about programming, but what's something that you want to learn next?
Great question. I'm actually. Maybe it's because I'm getting older. I'm trying to figure out how to take care of myself a little better. So I'm interested in kind of health. And are there ways to do that? Are there dietary or hacks? Like I just got a walking pad to sit under my desk, and after we get off this, I'm gonna I raise my desk and start walking on it. So just little like life hacks, I guess.
Is it
to help live longer?
Not quite a treadmill. It's like
it's a treadmill, but it's just a small one. It's abbreviated treadmill with it's just a pad on the floor, so it's really inexpensive, and it just lets you. And I already had a desk that could raise, and so now I'm like, oh, this is cool. I can just be on a call or just walk.
Yeah.
So that was someone shared that one. That's a good idea. And pickleball, I'm kind of picking up more pickleball, cool. And that's a fun one. Yeah.
Yeah. All right. Well, we mentioned a ton of things, but what would be a good way that people can follow your work online?
Yeah, great question. I mean, I am LinkedIn is actually where I'm probably the most active these days.
Okay.
Occasionally on X, a lot on LinkedIn, and then that's probably the best place. At some point, I expect to be publishing more, but probably will be later this year. So,
do you mean in social media or on like a blog or something?
So no, like on a blog or a Substack or something, or a series of. I really want to kind of start communicating about the lessons learned over the past years of entrepreneurship and open source, and helping people who are also interested, maybe pass along some of the tips and tricks and ideas. And
that sounds great.
Because what my long-term retirement plan is actually my incubator, like otincubator.com. That's where everything else I do is kind of from there.
Okay.
I do consulting. I'm working with OpenTeams to help it grow because I'm really passionate about AI sovereignty and people owning their own AI. But I need other people to partner with. Like that's I don't mind being an early stage CEO, being an early stage, get a company off the ground. And maybe someday I may, not saying I never do a later stage CEO work, but I actually love to empower other people to do that. Like that's my favorite thing, is to actually find other people who I can partner with and they can take it farther.
Yeah.
So that's what I expect to do that a long time. So OT incubator, and what we do there, like we're in talks about, engaging with other venture funds, and maybe I'll kind of merge that with more venture fund activities. So, but for now, LinkedIn is a great way to connect with me. And if you don't hear from me, I will eventually, find you there. Or you can email me at travis@openteams.com.
All right, cool. Well, Travis, it's been fantastic to talk to you.
Great. Thank you, Christopher. It's awesome to talk to you. Really appreciate what you're doing.
Oh, thanks. And don't forget, if you're working with any timestamped data in your Python projects, you owe it to yourself to try the right tool for the job. InfluxDB makes time series data effortless. Whether you're building analytics dashboards, monitoring applications, or tracking performance metrics, join millions of developers who've already made the switch. Get started today at influxdata.com/realpython and see the difference the right database makes. I want to thank Travis Oliphant for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.